OK. So guys, what we're going to do is they want us to transform this over the y equals x line. So there's a couple things. I'm sorry, they want us to reflect this over the y equals x line. So there's a couple things that we learned last class period when talking about reflections over the y equals x line. The first thing is when we have a coordinate point that, it could be a rogue coordinate point, meaning by itself, or it could be a coordinate point that makes up a parallelogram. If we have a coordinate point and we need to reflect it over the y equals x line, to find our new transformed point, we just reflect the x and the y coordinates. I'm sorry, we just swap, right? Swap the x and y coordinates. So that is the operation to reflecting over the x equals y line. But I'll show you guys graphically and algebraically how to do this. So the first thing we want to do, though, is let's graph this figure. So r is negative 2, 3. 1, 2, 1, 2, 3. So since I plotted r, I label it, right? Then I do 2, 4. That is s. T, 2, negative 3. And then u, negative 2, negative 4. Is that right? Oh, that's 2, negative 3. Sorry, guys. I wrote this wrong. That's s. T is 2, negative 3. And u is negative 2, negative 4. OK? Does everybody see that parallelogram? OK? Now, all I did was I plotted the points. Now, there's a couple things. If you guys remember, when I was showing you guys how to reflect over the y equals x line, I actually showed the line of reflection. The y equals x line is represented by this nice little pink line. All right? If you were to use a table to graph y equals x, that's the line you guys would come up with. OK? So there's my point y equals x line. And now what I need to do is reflect this. Now, you guys could try to take this. Remember the last problem? I just said, hey, flip it over the line, right? And notice the differences. This might be a little bit difficult for you guys to be able to do that on. So a lot of times, I just prefer, rather than trying to take your line of reflection and reflect the graph over that, let's just algebraically find out what the new points are. So remember, if I have my original points, and now I'm going to reflect them, my new point, r prime, is just going to be 3, negative 2. S prime is 4, 2. T prime is negative 3, 2. And U prime is negative 4, negative 2. So do you guys see how kind of simple that was as far as reflecting over the x equals y line? Jared, all we need to do is just swap the x and the y coordinates. So now let's go and plot what these points look like. And make sure you label them. R prime is 3, negative 2. So 1, 2, 3, negative 2. S prime is 4, 2. 1, 2, 3, 4, up 2. T prime is negative 3, positive 2. And U prime is negative 4. 1, 2, 3, 4, negative 2. Now I can connect these. OK? I know, guys, I'm not doing it the best job because I don't have a coordinate grid. But can you guys see how this is reflected over this line on that graph? You guys see how that's reflected over that line, y equals x? OK? So that's all you simply do to reflect over the y equals x axis. Thank you.